addition called Anti-Markovnikov. So we saw that the last reaction of HBr was Markovnikov. So the following reaction was observed. So if you take your double bond, that's your nucleophile, and add HBr, but in the presence of peroxides. Now peroxides, you've probably seen before. H2O2 is a peroxide. Sometimes they're written as a R2O2 or an ROOR. So if you see that written under the arrows, that's usually an indication of a peroxide, actually. All right, let's look at the mechanism and let's talk about what's happening here. So as we look at the mechanism here, the first step is initiation, right? Remember, free radical reaction has initiation, propagation, termination, just like we saw in the free radical reactions in our chapter 4. So we use the fishhook arrows and we form two peroxide radicals here that then react with HBr to form the bromine radical. Okay? Notice that often we need heat here to get that to occur. Now in the propagation step down here below, we can see what happens next. So remember that in the propagation we need to consume a radical and we need to produce it, right? So that the mechanism propagates and feeds itself. So we add bromine. Now bromine can go either to the end, right? Here. I don't want to use a dot there. It's kind of confusing. It can go to the end. How about that? Right? Or it can go to the middle. If it goes to the end, it puts the radical right over here. Right? So that's your radical. That's a tertiary radical. If it goes to the middle, it produces a primary radical. That's not formed. It's just like the carbocation. So the point here is to notice that the trend still follows that we form the most stable intermediate. But in this case, bromine radical adds first. Right? In the last case, H added first. Right? So we take our radical that's here, and now we need to add H. So we go through, you got your HBr, you got your arrows here, and then you get your H at the less substituted carbon. And we call that anti-Markovnikov. So in summary, when we look at this reaction, and we can see that there's a different regiochemistry here. Right? So if we have HBr just by itself, right, if we have it by itself, then what happens is it goes through, right, kind of this intermediate. So H would go to the end. So CH2 here, H adds there, plus charge is there, right? And we're not going to write the mechanism out, but that would happen. And then bromide would attack that carbocation, and because it's planar and sp2 hybridized, we could get a mixture of different stereoisomers like this. Now, quick quiz, chapter 5 quiz, what's the relationship between those two structures? Well, if you said they're enantiomers, then good job, you're correct. Down below, bromide adds first, right? The bromide radical adds first. So what we're going to get there is this guy, right, with our radical right there. And then H adds to that position because right, that's not a chiral center because there's already an H, so it's going to gain another H. So we would only get this as our only product. So only product here. So the utility of this reaction is sometimes we carry out these things called multi-step synthesis, in which we want to have the bromo group be interior, right? And sometimes we want it to be at the end. So we can use these two different reagents to distinguish between where we see those types of addition.